Hello M1, this is Teacher Win and I want to say Happy New Year to all of you. So for this video, we are going to learn about the layers of the Earth's atmosphere. So for this video, we are going to talk about the layers and then what else? So what are the variation or the changes of temperature in each layer? And also, we are going to explain or to learn about the importance of each layer and the boundaries between them. So in our previous lesson, we've learned about the composition of the Earth's atmosphere. So we have here two main gases. We have your nitrogen, which is 78%, and your oxygen, which is 21%, and as well as your trace gases. So they are called trace gases because they can be found in very small amounts. So we have here like your argon, your carbon dioxide, we have here your neon, helium, krypton, hydrogen, xenon, ozone, and radon. So this time, let's talk about the layers of the Earth's atmosphere, starting from the top, going to the bottom. So you just imagine the word layers are like your levels, or like the steps in your staircase, by which we stop from the top, then going to the bottom. So from the top, so we have here your thermosphere, thermosphere. Then we also have here your mesosphere, mesosphere, stratosphere, stratosphere, and lastly, we have your troposphere, troposphere. So this mesopause, stratopause, and your tropopause, these are like the stoppers or the layer in each major layer. Okay, so like for example, so this one here is we have your thermosphere and we also have here your thermosphere. So your mesopause is in between thermosphere and mesosphere. So we are going to learn more about these layers in our next slides. So by the way, so for more information about this Earth's layers, so you can check your science book 2 on pages 46 to 47. So before we go to each layer, so let me just share to you some tips on how to remember the correct arrangement of the Earth's atmosphere, starting from the top, going to the bottom. So we call it as your mnemonics. Mnemonics. So the mnemonics go like this. So thermosphere, so we can just say the monkey sings terribly. So say it again. The monkey sings terribly. So what does it mean? So T here is your thermosphere, M here is your mesosphere, S here is your stratosphere, and T here is your troposphere. So again, the mnemonics of Earth's atmosphere is the monkey sings terribly. So also we are going to talk about this graph showing to you the changes in temperature of each layer. Because in one of our goals, so we have to discuss and know also the different temperature of each layer. Okay, now let's start from the bottom layer. So the layer that is near the ground. So we have first your troposphere. So what do we know about troposphere? So it is considered to be the lowest and the thinnest layer of the 4 or sometimes 5 layers of the atmosphere. So near the equator, so equator is an imaginary line that divides the earth into north and south. Okay, so countries that is near the equator, so we have like Thailand, Indonesia, Philippines. So near the equator, so the troposphere height is about 16 kilometers. And then for the poles, or shall we say the North Pole and the South Pole, so the height of your troposphere there is only 8 kilometers. So you might be wondering, why do you think it's higher in equator and lower in 8 kilometer, in poles, I mean. So what do you think? Okay, so that's because remember that in Earth, so the equator is receiving more heat compared to your poles. So that means, so the equator here is more hotter than the poles. So remember that the rule in your kinetic particles, right? If it is too hot, then the air molecules will be moving faster and they will spread apart, right? However, in your poles, which are colder, so the molecules does not move around that much. So that's why, so if they move very fast and they spread apart, so that will explain that the atmosphere height near the equator will be higher compared to the poles. Next. So 90% of the atmosphere's mass. So basically, so as we all know also, so the molecules are held by the gravity. So most of these air molecules are staying in the troposphere layer. And also, so please take note of this one. So in your troposphere, so temperature decreases with altitude. So what is altitude? That means height. So meaning as we move up, then the temperature starts to decrease or lower down. So here's like an average. So it says that for every kilometer, so the temperature is lowering down by 6 degrees Celsius. So basically, so the troposphere temperature will average about minus 50 degrees Celsius. So this is just an estimate. And please take note that weather conditions usually happen in your troposphere, like your snowing, like your typhoon, your tornado. So every weather experiences that we had or we have or we will have to experience near soon. So that's this is where you will experience those in your troposphere. And then please take note also, this is like a boundary between the troposphere and the stratosphere is what we call your tropopause. Okay, so this is like the graph that shows you the movement of the temperature of your troposphere. So remember that in troposphere, as we go up, so if we look at it here, the numbers here is in kilometers. So 0, 10, 20, 30, 40, 50. And then this side here is the temperatures. This is going to the left means minus, negative. So minus 20, 40, 60, 80, 100. Going to the right side, so the temperature is increasing. So it means it's getting hotter here. This side, it's getting colder. So in troposphere, the temperature is getting what? It's getting lower as we move up. So that's why, so starting from this point, so as we move up, so the temperature is getting colder or getting lower. So here, this is like an estimate. So it's in between minus 40 to minus 60 degrees Celsius. Okay, now we have your stratosphere. So in your stratosphere, so it extends 10 kilometers to 50 kilometers above the ground. So the height of your stratosphere, starting from the ground, going up is about 10 kilometers to 50 kilometers above the ground. Also, it is less dense. So meaning it's not that heavy compared to your troposphere. So that's because there will be less water vapor or less air molecules staying in your stratosphere. However, please take note of the temperature. So the temperature in your stratosphere is increasing. So that means it's getting hotter in stratosphere. So don't be confused. In troposphere, as we go up, it gets colder. However, if you go with stratosphere, it's getting hotter. Next, we have your, okay, so almost no weather occurrence. So meaning there's a less chance to have like typhoon, your tornado formation here in the stratosphere because most of those conditions or weather conditions can be found in your troposphere. So please take note that this layer contains high level of ozone. So your O3. So remember that your O3, or shall we call this layer as your ozone layer, this red layer. So it protects the earth, or it protects the living things from the ultraviolet rays or the UV rays. So this ozone will absorb or will reflect some of these UV rays, because the UV rays can cause skin cancer to humans. So thankfully, we have your ozone layer that protects us from developing your skin cancer. Also, in this ozone layer, so with this one, so it helps to trap the heat. So this ozone layer is like, you just imagine as an oven as well. So as an oven, so not that too hot, so it will just maintain the warm temperature of Earth, or else Earth will feel or be like an icy planet without this ozone layer. So basically it has two functions. So number one is to protect us from UV rays, and number two, it helps the Earth to be or to maintain the warm temperature. Next. Okay, so please take note that the upper boundary is called your stratopause. Okay, so this is like the stratopause, the boundary between your mesosphere and your stratosphere. Here's the graph that shows the movement of temperature in your stratosphere. So please take note, so as we move higher in the stratosphere, the temperature is getting higher, or shall we say it's getting warmer here, thanks to your ozone layer. So this is like the visualization of the first two layers. So in your troposphere or your tropospheric ozone, so it is here where you can find most of the clouds. And then the next layer, which is your stratosphere, so we have here your natural protective ozone layer. Okay, next we have your mesosphere. Your mesosphere. So your mesosphere, so it extends to almost as high as 80 kilometers. So it's already far or higher already compared to your first two layers. So here the gases are less dense. So it means that as we move away from the troposphere, so you can find less gases as we move up. Okay, so if you compare mesosphere and stratosphere, which one is lighter? So your mesosphere is lighter than your stratosphere. If we compare stratosphere and troposphere, so your stratosphere is lighter than your troposphere. Also, please take note, so in your mesosphere, so once again, the temperature here is decreasing as we move up. So gases in this layer absorb very little UV radiation. That's because most of the absorption of the UV radiation or the ultraviolet radiation is being performed in your ozone layer. Also in your mesosphere, please take note, so this is where, or this is the layer that protects the Earth from space rocks that will enter and slam the Earth. So in here, so your asteroid will be burning in this side. Okay, so or any space rocks that will enter in our atmosphere. So this is the layer that burns those space rocks. So here's the graph that shows the movement of temperature in your mesosphere. So as we move higher, so it's getting colder. So the temperature in your mesosphere can reach in between minus 80 to minus 100 degrees Celsius. So please take note, here you have the next boundary. So mesopause, so that's between your thermosphere and also with your mesosphere. Okay, next we have your thermosphere or sometimes called as your ionosphere. So in your thermosphere, so it's above already 600 kilometers from the ground. So it's very, very high. And then next, the temperature here is increasing. So with altitude, so please take note, the temperature here is increasing. And then what else? So it readily absorbs solar radiation. So basically, so this layer is like facing already the outer space. That's why, so your thermosphere or your ionosphere protects the Earth by absorbing the solar radiation. Solar meaning sun. So the radiation from the sun, so your thermosphere will help us to be protected from this radiation. Also, the temperature can go as high as 1,500 degrees Celsius, and it reflects radio waves. So these radio waves is one of those EM waves, or your electromagnetic waves, that is responsible for long distance communication. So that's the reason you might be wondering, how do scientists get information from the satellites or from those space shuttles or your space probes that orbits the Earth or orbits the another planet, and to think they don't have wire that connects Earth to them, right? So those information from those solar devices or from your space devices, so the information is transferred through these radio waves. So however, your thermosphere is somewhat reflecting, so meaning some of the radio waves cannot enter the Earth's atmosphere. Okay, so that's the purpose of your thermosphere, to reflect some of these radio waves. Okay, so this is the temperature movement with your thermosphere. So it can reach up to 1,500 degrees Celsius. So it means it's getting hotter here in your thermosphere. So again, so in your troposphere, the temperature is getting colder, getting hotter, getting colder, then getting hotter. Okay? Now, one of the most beautiful events that happens in Earth's atmosphere is we have here your aurora. Aurora. Sometimes it is called as your aurora borealis. If it happens that you find it in the North Pole, and then we also have here your aurora australis. So if you happen to find them near the South Pole, so this aurora, unfortunately, we cannot find them in or places near the equator. So if you want to see this aurora, so you have to move to countries near the North Pole, such as your Russia, your UK, Canada, okay? Or in South Pole countries like your Australia. So if you want to see this beautiful event, so just go there. So let me just share to you a short information about the formation of this aurora. So basically, so there's an extra layer here. So we call it as your magnetosphere. So you just imagine Earth as a big magnet. Just like the magnet has North Pole and the South Pole, right? So this is the North Pole and this is like the South Pole. So Earth is a big magnet. So this magnet-like property of Earth protects us from the solar winds or from the strong energy from the sun. Okay? However, when the sun releases a very strong energy, so some of this energy will be bumped, it will hit here and then will be like bounce or reflect, right? So as they reflected away, some of those energy will enter in this area. It can be in the North Pole area or in the South Pole area. So basically, so as those energy is hitting the air molecules or air particles of your atmosphere, So as they hit each other, so they create like tiny bombs of energy. So these tiny bombs of energy can be shown as lights. So that's why you have your aurora formation in this area of your Earth, the North Pole, or the near the South Pole. Okay, so we have here like an extra layer of the atmosphere. So we have here your exosphere. Exo means outside already. So you just imagine exosphere as your outer space layer, by which, so it's the interface between the Earth and the space. And then atoms and molecules can escape to space here. So meaning there is a less influence of gravity here because it's already far away from Earth. So that's why some of these molecules or atoms, so they can freely escape going to the outer space. So just a recap of those atmosphere layers. So we have here from the bottom troposphere, stratosphere, meso, thermo, and exo. So the monkey sings terribly. Teacher, there's an E here. So what should we do? You can have like ET, extraterrestrial monkeys. So ET monkeys sing terribly. Okay. So in your troposphere here, so we have here the weather conditions. In your stratosphere here, this is most of the planes will fly. And then we also have here your mesosphere. Space rocks are being burned here. In thermosphere, most of the space satellites that we have right now, so they orbit here. And then with your exosphere, so this is where your most of the spaceship will go into fly, because as what I've told you, your exosphere is like the connection now of the Earth and the outer space. Okay, so let me just share to you about this so-called ozone depletion. So ozone depletion meaning the ozone gas or the O3 gas in your stratosphere, so it's getting lower. So what do you think will be the effect? So the main cause here, or the main reason of the ozone gas to go down, is because of your CFC pollution. So I hope you still remember this word, your chlorofluorocarbon. So this chlorofluorocarbon, so right now we are not using this one because it can damage the ozone layer. And then, so with your ozone depletion, so the radiation from the sun causes the CFCs to break down, and they can release a chlorine atom, by which this will react on the gases or the ozone gases, forming the oxygen gas and the chlorine oxide, your ClO. So this is like a bit explanation of how does your CFC causing damage to your ozone layer. Also, with your ozone still, so if your CFC will destroy your ozone layer, if we will continue to use it, so it's damaging, right? So that's why we stop using those CFC products. And however, even if we stop using the CFC products, we still have lots of cars, we still have lots of factories, we still have like many activities that that involves burning. So as a result, so even if we are not using CFC, but still we are slightly increasing the temperature of the Earth. Because remember, I've told you that your ozone layer is like an oven. However, it's not that very hot. However, it will just provide a warm temperature for the Earth, right? So as a result, if we keep on using cars, building more factories, more of burning, so slowly we are increasing the temperature of the Earth, which in result, we can call it as your greenhouse effect. The greenhouse effect. So the greenhouse effect, so it comes from the word greenhouse. So greenhouse is like a house wherein you put plants, and then the greenhouse will somehow control the temperature that surrounds your plants, so it will not be too hot or not will be too cold. So this greenhouse can be applied also in our atmosphere, and that's what we call your greenhouse effect. So it is the trapping of heat by the gases of the atmosphere. So these gases are what we call your greenhouse gases. So we have here your carbon dioxide, your sulfur dioxide, ozone, CFCs, and water vapor. So basically it's just like this. So if this will be Earth, okay, so this will be Earth. Let me just draw here two Earths, half Earth. Okay, so before, so the ozone was like not too thick, not too thin, just like this. So basically, so before, in your ozone, or shall we say before, if there's like heat of the sun, that we just represent it by arrow, so this heat of the sun will enter into your atmosphere, right? So they will enter here. However, some of the heat will be reflected back. So that means some of the heat can escape, and then some of the heat here can escape as well. However, some of the heat will just stay here and be bouncing back. Okay, that's the normal before. However, with the use of your greenhouse gases, your ozone layer is now very thick. So it causes your ozone layer to be thick because of these greenhouse gases. So still, the heat from the sun can still enter the earth. 1, 2, 3. However, because of its thick ozone layer, due to your greenhouse gases, only small amount of gas, or I mean small amount of heat can escape. However, most of the heat here will stay inside. Remember that we are now in the period of industrialization, so meaning we burn more fuels, we use as cars, we use factories, so we're adding heat from the earth, and then plus the combination from the heat of the sun. So we're not like burning. I mean, we're now like in an oven, really. So I think you've noticed the temperature right now, right? It's already December, and yet you feel like the December is like summer. Supposedly December should be cold, right? But right now you can feel that it's like there's an abnormality. It's like not normal already. Okay, so I don't know if you've heard or read some news about some countries like in Alexandria, Egypt. So it happened to be like there was an event that there's a snow. I think it happened like December first week. So I'm not sure about the date. So it really snowed, by which normally they will have like a cold December, but not to the point that it will snow. So that's because of your greenhouse effect. And then as a result, so we have like Earth is getting warmer. So the weather before and now, it's really different. So one of the main impact of your greenhouse effect is your global warming. So the Earth is getting warmer. So what will happen? So ice in the polar caps will begin to melt. So the polar caps, like your glaciers in your North Pole and your South Pole, are getting or are melting, or shall we say the big chunk of ice. So they start to melt, and then the water in the ocean expands. So meaning the ocean level is getting higher because the ice now is melting in your North Pole and South Pole. And then of course, so as the ocean gets higher, so some of the lowland areas so are getting flooded. So I don't know if you've read about news about Venice, Italy. So it's one example of a lowland area. So frequently they are receiving flooding. So in the near future, some of the islands or some of the countries which are classified as lowlands might disappear from this planet because they will be covered with ocean water or sea water. And then also in even coastal areas. And then also there will be changes in the weather patterns. So before, supposedly we will experience a cold December, but right now it's January, and yet we feel like it's summer already. Okay? And also there are also some places in around the globe that supposedly it's winter, however, snow has not fall yet. Okay, so for your homework, M1, so please answer page 49 to 50 of your book. And then you don't need to do the experiment there. Just simply answer the activity in page 49 because it's about the layers of the atmosphere. And also, I will be forwarding to you a worksheet, so please complete it. And when you're done, send it to the Google Classroom. So this is the end of the lesson for this video. So I hope you've learned something about the layers of the atmosphere. And don't forget to do your homework because you still have plenty of time. So thank you very much for watching and have a nice day. And once again, Happy New Year, M1.